Okay, hello everyone. Trying a different setup today. So there is some background music. Hopefully that makes the experience a little bit more engaging also for me. So yeah, I guess we can go ahead and just continue where we left off from last stream. Um, I remember one of the so like a mini recap. We were about to implement the learning rate schedule, but also offline. I remember last time we got stuck because the open web text dataset was too big. Uh, and I mean, it just occurred to me like, why not just use mini Shakespeare dataset? So I guess um, part of we can what we can do today is yeah just use that data set um, for for today. So let me let me just check that we are actually streaming. Okay, yeah, stream is good. So yeah, let's maybe we can do both of that. I think today we can complete the training loop. Um, mm, if if there's if there's any inconvenience with the music, somebody please tell me. Um, so okay, uh, we were playing with train.py. If I remember, we got to a point where we actually implementing like a training step. We haven't tried it out, but before continuing, um, we have to do a couple of things. First, um, let's fix the data set issue. So the dataset issue was that here we weren't actually loading the data. We were just creating like some random samples. Uh, Maybe let's put a comment here. Uh, random random samples. This was like our version, the original version was this. So in this version, we we need this to be okay, but for this to be okay, we need sort of the data set to be available, and I guess we just copy here uh, the okay, it's just copy the Shakespeare dataset. I guess we do have to Shakespeare. Uh, okay, so it's just running prepare Python prepare. So this one should be quick. The open web dataset we got. Okay, yeah, it's super quick. Okay, yeah, should have done that last stream. Um, I guess I'm gonna do a stream where I actually try to, or might just do it offline, try to train with the open web text dataset. Okay, this was one issue that we can try now. So maybe let's just run this code and just see that we have the data. Uh, so okay, we're gonna try to look at the chat periodically. Um, so yeah, we do have the data, as we can see here. Contrary to last time where we mocked it, but I think we're good. So the next thing we have to do, uh, by the way, is the volume of the music okay? If somebody is watching, that would be a good feedback because I hear it a little bit different. Um, okay, next thing we have to fix. This is more of a JAX issue. In JAX is not so easy to modify like the learning rate on the fly. Well, there are tricks, but what Optax does, Optax is like the main library we use in JAX for optimization, is that it has some schedules. So I think what we have to do is actually use that. So uh, I guess what we can try to do is code like a schedule, and then we will have to pass it to the constructor of the optimizer. So we will see how to do that. But for now, let's here maybe just code like a schedule function. So we can do like a schedule. Uh, and okay, yeah, Copilot is helping. So we don't have Optax here. So we will need Optax. Let's pause the debugger. Uh, we will need Optax. Sorry. I do I have my dependencies? Poetry. Sorry. Yeah, I do have my dependencies. Let me just check. Let me scroll to the top. Okay, let's just import Optax like this. And okay, we do have Optax now. So there are like a couple of functions that allows us to create like schedules. So we want to reproduce this logic. One of those is a piecewise constant scheduler. So and then there's a linear schedule. So there's like a couple of schedules. And you can mix them, right? So maybe piecewise constant. So this one we need to sort of create like the composition. So what we want to do is we want to create like a linear warm up, which is this phase, and then so the second part is learning decay iterators. Okay, let's just see a couple of things. Okay. So before 2000 steps, we want to have the linear warm up, and after decayers, I think we've reached like the maximum. We just return the minimum, and then in between, it's a cosine decay. So we want to express that, and we shall see like what is kind of the easiest way to express that with what Optax has. So okay, a map from boundaries to non-negative schedule returns. So yeah, I don't think we can use this. This one, what it does is that it sort of has like products, uh, but it just allows, yeah, it's a piecewise constant. We need a piecewise, else we will maybe just have to code it ourselves and just convert what we have here to JAX piecewise interpolate schedule. Okay, uh, let's see, is this one good? It joins a function which implements a piecewise interpolate. Um, no, that one is interpolation. We need like a, I don't know if they have it like a piecewise, and in between those piecewise we want like a function, not like an interpolation or whatever. Like we need them to give us um, like full control. Else, I guess we can just code it. Um, but ideally, we just reuse something from Optax. Mm, okay. See your schedule. No. Let's maybe just code it ourselves, because these ones are so okay. Yeah, this okay. We have a couple of options. We can either do this logic on Python and then pass this to train step, and then we have to do a little trick so the optimizer takes this into account. But yeah, that will just reveal some of Optax weaknesses. Um, Alternatively, which is I think what we're going to do, we're just going to express this in JAX, and that will be the solution. So yeah, one thing we have to do is that JAX, you cannot just do like control flow using like Python. You have to transform it a little bit into using either cond or switch, which are so so you have to use either jax.lax.cond or jax jax.lax.switch. So cond is just like a single if, but here we have three branches, so I guess we will have to use a switch, which is kind of the generalization of cond. So what so we have to create like three functions. Sorry, we will use switch. So basically this what it's going to do is that uh, we're going to try to calculate like an index. It's gonna be a little bit funny. Uh, and then using that index, we are going to execute one of these functions. Yeah, that's kind of the idea. So yeah, so basically this is going to be like 0, is going to be 1, and this is going to be 2. And then we're going to create like three functions. Um, I guess the question or the problem is how to do that with JAX. So what we can do is create like an index, and then that index, well, it's going to have a bit of a funny form. I don't know if we can generalize it, but basically we have to. Okay, uh, let's see. Okay, so this is where Jax gets a little bit funny. Uh, so so we have to create like the index, and how I think I'm gonna do it, I'm just gonna express this same three conditions here. So we have 1, 2, and let's see. We have kind of the last one, which executes always. Um, so index, so switch, semantically equivalent to this. Um, I guess the last one is true. Something like we need something equivalent to true. So maybe we just put like a 1. Um, so maybe we have like a 1 here. Um, and then what we have to do, which is like a little trick, um, is get the index of the first one, in this case the first one, which is true. So that would be either this case, or this case. And for that, let's see. Um, mm, had done this once already. Let's see. Let me remember the trick. Um was it using sum? Let me remember. Um, so IDX. So we have this little vector, and there was a way to tell it like, hey, get the first one um, that is not true. Uh, okay, just a second. Okay, I think we need something like IDX range, uh, which is something like JNP dot range 3, like a range, and then so this gives us the index, and then we need a way to have it select the first one that is not true. Actually, maybe this function has to do something similar. Let me check. Maximum sign boundaries and scales. Schedule. Okay, this one is like a for loop indicator. Feel there should be an easy way to do this without getting, like, I could do like a double cond, but that would be a little bit ugly. Although I think, yeah, I don't know. If we do a double cond, that would be super easy. But I feel there should be like an easy way to do the switch. Like, we just need a function that gives us like the index of the first true statement. I, I don't know, just for fun, I'd like to maybe define that function like def first true, and we have like a like a bool array, and it should turn the index of the first true value. Okay, Copilot is suggesting where, just using where. That I don't think that is correct. Index of the first true value in the array. Okay, let's see if Copilot import JAX.numpy as GMP a bool array. equals GMP array a false true true a okay. Yeah, I don't think where gives us what we want. GNP where, but I just want to see bool, bool array. It's thinking. Mm, okay, this is no, it's not good. Okay, maybe yeah, yeah. Say with like a range. Let's see. Uh, IDX. Hmm. Okay. Maybe we can sort it. Yeah, maybe maybe we can do like an arg sort. Let me try that. IDX. Uh, yeah, I think this is more arg sort of bool array. Uh, but let's see. IDXs equals GMP the arg sort of bool array. And here probably want order. We need to reverse it. Axis order. Okay, the only thing I want is to reverse it. Let me see this kind of a little. What if we just do like the negation? Okay, yeah, we just have to sort. And then just pick the first one, and I think we're good. I think this is what we want. Okay, it's a little bit weird, but this gives us our answer. So I'm gonna put true here, and then I'm gonna create like an array. Um, and then our it's gonna be like the condition const, and then our IDX is going to be first true of the conditions. Maybe let's just do something like this, so it reads a little bit more natural. So yeah, and then okay, and then the value that we want to extract is so these are like our index. Uh, Let me just cons. Okay, so these are conditions, and then we have mm, let me now we have to create like our functions. So our functions would be I guess we have to define them. So this one will be like dev okay, warm up will be like a lambda with deter, and then just kind of this formula. Okay, that is warm up. Okay, I guess case. Yeah, this is a little bit weird. Yeah, we can code it a little bit different here. Um, I know, yeah, we still have to follow that logic. Uh, I guess constant could be like this case, and then this other case. This other case is the cosine decay. Maybe we can reuse optax. So cosine. Okay, yeah, not. Ah, it's reusing these variables. Uh, yeah, actually, I'm just going to refactor this because like step because iter is like a reserved word. Um, so okay, optax has like a cosine decay. I don't know if we can just reuse that. So cosine optax dot cosine decay schedule. Uh, it has the decay steps, init value, and an alpha. Mm, what is the init value in this case? I guess it starts at learning rate. Um, so this one grows until learning rate, and this one p decay ratio. This is a coefficient. Decay ratio step minus warm up it there. So this is just where we are, and so it's 0 initially. Cosine of 0, I guess it's 1. And plus 1. Hmm. Yeah. Okay, and then there's this other formula. So we cut it in half. A learning rate minus mean. For simplicity, we can just use this. So let's just like turn this into a function. Like def cosine step. Yeah, let's just do this. Uh, okay, just okay. I'm gonna comment this. And paste cosine here. So these are three conditions and their corresponding functions. I guess then we do have to calculate the index. Um, let's actually just do this here. Cons. And finally, so what we're going to return is just the index of all of these at step. So they all accept step. And yeah, this part I don't know. Maybe Switch should have like a helper for what I did here. Like this first true was a little bit sketchy to say the least. Um, I think it's right. So yeah, maybe let's for a second play with this just to maybe let's plot it. What would be the best way to plot this? Okay. Uh, I'm going to run this in a Python in a Jupyter environment. Uh, so okay, this is our first cell. Mm, let's move this function to the I don't know. Where do we create the optimizer? We create it here. Let's move our function here. I'm just going to delete this. Uh, let's change the API and do this here. I don't know, the conditions array. Uh, okay, this seems good. Uh, okay, I'm gonna run this until here. With a bit of magic. So this is gonna trigger this Jupyter environment on VS Code. And while that installs, what I want to do is import something happened. IP. Okay, let's let's comment this line for a second as the configurator is tripping us. Okay, here we are. So let's import matplotlib matplotlib dot guilty. Let's see. Ah, Mr. Cardozo. David is in the chat. David is promising to port this to Julia. Amazing. Okay, let's create like a range. jmp.range steps equals jmp.range of what is our max? We have like a max. um, of this, maybe plus 100, just to see how it looks. Um, and then the learning rates will be, I'm gonna do like a jax.v map of our learning rate function. Where are we? And then this will be steps. So this will be like our learning rates, and then okay, yeah, we have to remove this assert. Eh, yeah, just remove that assert and run it again. And now just plot steps with the learning rates. Okay, that looks fine. So yeah, these are our learning rate schedule. Um, okay, I think we can kill this environment for now. Although, okay, although it's kind of nice to run it. We can either use the debugger or just run it step by step. Maybe we can run it step by step. But let's close this for a while. We can come back to this. Um, what we really have to do uh, is pass the schedule to. I'm gonna rename it RL schedule. So I'm gonna rename it as a schedule. Let's just keep the original name. Um, and we'll have to pass it here. So maybe we. Oh, actually, the change is it's really simple. We can just pass it instead of get of the learning rate. We can pass a function. So like these atoms accepts either a scalar or a schedule. So we're good. Um, yeah, I think we're good with this. Um, so yeah, we didn't have to change our API, but we had to define the learning rate schedule. A little bit funny. Um, let me inline this here. Um, just so it doesn't clutter the rest. This will be jitted, so doing this here doesn't matter. Um, okay, this. Okay, yeah. Let's see. Let's see where we're at. So let's again initialize like our our state. We have like an error. Expected expected dict got frozen dict. Uh, we have like a disagreement. Let's see. Create. Um, expected dict got frozen dict. Okay, I think I see where this comes from. Let me kill this. Uh, so if I remember correctly, params, we're kind of modifying it a little bit. Like here, it's a frozen dict, uh, but here it is not because path aware map. I think path aware map. I think freezes it, so we have to freeze it here. Freeze. We have to freeze it here. So we have to turn into a frozen dict. So from flax dot oof, is it core? Import freeze. Yeah. Okay. I think yeah, I think this might be the solution. I can try running again. And okay, we have a problem again. Let's see what it is. Expected dict got frozen dict. So let's just check this manually. Type of params. Sorry. It's a frozen dict. Hmm. Okay, let's run this in the debugger instead. Let's try to run until here. Because maybe it's stopping at another place. Okay, one possibility I think that could be happening is uh, that param partitions we have to freeze it as well. Yeah, anytime we use path aware map we have to freeze. Maybe we should just can send a PR to Flax to to avoid this. Let's try this again. Okay, yeah, that was it. Um, so it seems we're good again. Um, okay, we fixed the get the learning rate issue. Uh, so we implemented the learning rate, which was a little bit harder than I thought. Um, mainly this first true. Uh, the training step is actually really easy because we'll see later, but we actually don't have metrics here for now. It's just like the loss. And we'll have to see what estimate loss does, which I think it's the thing we need to fix next. But it it seems to just like run for a couple of samples and get the mean. So eh, I guess we can try to do that. So we don't need this. Um, out. What is split? Okay, it's gonna do it for the split. Yeah, maybe the only thing we can improve here is uh, we have to maybe JIT this part. We don't want to run this part like eagerly. So maybe we can create a function called maybe forward, and then it gets a state, it gets a batch, and it gets like a train ball argument. Um, and it will basically just compute this part. Can even reuse it. Okay, batch. Yeah. Huh, it's a little bit weird defining. Yeah. Yeah, our batches always have the labels. It's a bit weird, but yeah, we can use it. So we'll just return this, like always. Um, so maybe this is here, and we use state.params. Oh wow, this is a bug. State.params. No, it's not a bug because here we're mapping. But here we need to use state. Mm, actually, the most general thing is use apply apply fun here. Uh, So we have this forward. Mm, yeah, actually, we can just implement here like forward. Yeah, like this. But for compute uh, loss, we can put here forward state. So just batch maybe. So we don't destruct it for nothing. We don't have a context. I think that's kind of a PyTorch thing. And then this is just going to turn it into like a scalar. I think we can do float of the loss. That is a little bit more aggressive. And losses. Okay, we're storing it in an array. Yeah. So yeah, I don't know why this has to be like a PyTorch thing. I think it can just be like a NumPy thing. Out. Okay. Oh. Wondering if we should execute this in training mode. True for no, because we're in eval mode always. So yeah, we don't have this and we don't have this. So we're always in eval mode, so that is training false. So yeah, I think this code is good. Um, okay. Is this false? Yeah, okay, this is false. Okay, training loop time. Param group. It's like a lot of stuff here. Um, okay, yeah, this like yet another schedule. Like okay, either constant or just learning rate. I think we have to do this elsewhere. Let's put this where we define the learning rate. So so maybe oof, I don't know what this params groups is, but their schedule equals get get learning rate. Else it's just constant. Maybe Maybe this logic is, is kind of the same. Um, wonder if we should just create like a simple training loop, um, and then copy some stuff from here just to test. Um, maybe even just like can we get here? That could be like interesting. And I think we're running out of time. Yeah, let's see if we can get here. Ah, this is not good. Have to do forward with the params. Um, yeah, makes sense. Ah, okay, no. Ah, what do we do? Uh, it's better to do it with the state because we can use a fly phone. But then here we have to state. We have to replace the params. It's kind of a little hacky. Like have to replace them with tracers from grad. Okay, with this, let's see if we can reach. Can we reach here? Actually, so um, yeah, let's just run this. Okay, okay, wait. We wanted losses. Ah, sorry. Losses is not defined. Okay, do we have state? Okay, we did reach here. We didn't reach here. Okay, let's see. Seems like a better job for the debugger. Get batch. High. Okay, it's kind of a bug. Low is greater than high. Mm, is it like a difference in the API? Let me see. I think maybe we have to specify size here. Size. Randint. Low. High. Uh, is it size? Yeah, size. Okay. stuff is happening. Drop abstract trace encounter where concrete value is expected. Okay, train is a tracer. Let's see. Yeah. This has to be like a partial, like a static. Um, it's just from func tools import partial, and then let's apply a partial static argnums. Actually, arg names. So okay, let's see. It's doing stuff. I think we need to make it run on TPU, but I mean, yeah. Let me just install the poetry shell. Uh, let's install here pip install. Let's install JAX for TPU. Okay, are we good? I think it's jitting, so it will take a while. Okay, we got a result. That's and it's not nans. That is amazing. Uh, so I think this is very good. Um, we well, I mean, we still have to run the train step, uh, but we managed to have like an initial evaluation uh, of the model, uh, which is interesting. I think we now have to sort of port some of this logic One of the things we have to remove initially is uh, we have to change checkpointing to use flax checkpointing. We need to um, this should be calling train step, and yeah, I think there's not a lot to do, but I'll leave it for now. I think next time we'll actually start training, and we are nearing the end of the Nano GPT saga. Uh, so yeah, here would be training, and all of this is just logging and checkpointing. Um, so we're very close. Um, yeah, I'll leave it at this for now. Uh, hopefully, yeah, hopefully we um, can finish this in 1 or 2 episodes. And yeah, I don't know if anybody has comments. Let me know what you're interested in the comments, either on YouTube or on Twitter. Um, yep. See you on the next stream.